In this episode, we take a look at how Amazon has more than 200,000 mobile robots working inside its warehouse network, alongside hundreds of thousands of human workers. This robot army has helped the company fulfill its ever-increasing promises of speedy deliveries to Amazon Prime customers. But it also gave Amazon the technical foundation on which it could build new versions of warehouse robotics for years to come, setting the stage for a potential future where the only people inside Amazon facilities are those employed to maintain and operate their robotic replacements. You're watching Futurelicious, where we bring you the latest information on technology. If you enjoyed this video, consider supporting us by subscribing and liking the video. Much of the boom in warehouse robotics has its roots in Amazon's $775 million purchase of Massachusetts startup Kiva Systems in 2012. The tech giant rebranded it as Amazon Robotics and has transformed it into an in-house laboratory that for 7 years has been designing and building Amazon's robot armada. Amazon this year bought another warehouse robotics startup, Colorado-based Canvas Technology, which builds wheeled robots guided by computer vision. Such robots would be more fully autonomous than Amazon's current fleet of caged-off vehicles, which have to follow barcodes and previously mapped routes within warehouses. It's a symphony of electric whirring, with robots pausing for one another at intersections and delivering their packages to the slides. After each mission, they form a neat queue at stations along their periphery, waiting for humans to scan a new package, load the robots once again, and dispatch them on another mission. In effect, Amazon calculated that there was so much productivity to be gained from reducing the millions of miles its workers walk each year, that it was better off finding robots well suited to moving goods all those miles. Amazon runs simulations to figure out how to keep their human workers comfortable when loading robots with packages. This includes their range of movement from an ergonomic standpoint and their safety, or such questions as how best for a human to grab a parcel, scan it, place it, and reach over to hit the button that sends the robot on its way. A system in the cloud, sort of like air traffic control, coordinates the route of every robot across the floor, with an eye to potential interference from other devices and other routes. That coordination system also decides when a robot should peel off to the side and dock in a charger, and when it should return to work. Sometimes the route selection can get even more complicated, because particularly populous zip codes have more than one chute, so the system needs to factor in traffic patterns in deciding which portal a robot should visit. Beyond coordinating the robots themselves, there's the question of how to make them good co-workers for the human employees. The human's job is to place packages in 6-foot-tall boxes below the field, taking care not to toss in heavy packages first. To make that work manageable, the robots have to distribute packages between the multiple chutes for a particular zip code, so a given chute doesn't overflow. At the same time, the system considers how to best crew packages downstairs by their departure time, so workers don't have to run around hunting for them. The end goal is to minimize congestion through an even distribution of traffic across the field. So on top of the tweaking of robots' routes, the system can actually switch the chute assignments around to match demand, so that neither the robots nor the human sorters they work with hit any bottlenecks. In Amazon's robot-powered warehouses, drive robots are the main workhorses, making up over 200,000 of Amazon's fleet. These transportation robots navigate by using a series of computerized barcode stickers on the floor. The robots are equipped with a sensor preventing collision with each other or their human workmates. Kiva is the original robot supplied to Amazon, capable of lifting over 1,000 pounds. Kiva moves shelves known as pods around the warehouses faster for storing and picking. It fits nicely underneath the pod and lifts it away to its destination. Like most of the robots in the Drive series, it has a speed of 3 miles per hour, which is average walking speed. Hercules is also an original robot, developed back in 2007. It's designed for heavy-duty lifting, able to lift up to 3,000 pounds. The design is similar to the Kiva, but can lift more heavier weight. It is larger in all dimensions, so the pods it carries are also larger. There are also pallet-shaped pods, which are pallets on a frame with legs for the robot to go underneath. Pegasus is the successor to the Kiva. It performs the same function, however it is smaller and can lift 1,234 pounds. It is also cheaper, as it only uses half of the parts of the original Kiva. The Pegasus is also modular, as it can be equipped with a conveyor belt called the X-Sort drive. Instead of carrying pods, it sorts and transports completed parcels to the shipping. A worker places the parcel on top and carries it away to the corresponding chute down into the truck. Xanthus is a new, currently in develop model that will be replacing the Pegasus. It's also a drive unit that carries pods, but also can be fitted with different attachments. Sorting belts, reducing the number of warehouse conveyor systems, and mobile cabinets for packaging. The Xanthus is much thinner, has 1/3 of the parts, and costs half as much of the Kiva, reducing the maintenance cost. The RoboStone is a typical articulated robot used to lift pallets or boxes around. The arm has a reach of 12 feet and can carry up to 2,600 pounds. It can move pallets around with great accuracy, as it can place objects in the same exact location over multiple times. The slam machine, which are labeling robots, are the warehouse's bread and butter. 2 slam machines working side by side can label about 1 package per second. Thousands of slam machines are used in Amazon's warehouses. Prime Air, Amazon's experimental drone delivery service, is intended to bring parcels the last mile from the fulfillment center to the customer. They are currently able to fly up to 15 miles, carrying up to 5 pounds, and deliver within 30 minutes. Finally, we have the Amazon Scout. Like the drone, this is used to deliver the parcels the last mile from the fulfillment center to the customer. It's still in early testing, as it's only available near the Amazon headquarters in Seattle. Autonomous vehicles are another avenue Amazon has its eyes on. The company has invested in driving startup Aurora, which focuses on level 4 autonomy. That means the car takes over all of the driving in certain conditions. While most might assume it translates into moving people around in robotaxis, autonomy can also be applied to the movement of goods. Amazon has also been testing self-driving trucks powered by self-driving freight startup Embark for automated shipping. Zoox is another acquisition Amazon has acquired, seeking to build a fit-for-purpose self-driving passenger vehicle from the ground up, along with the software and AI, and to provide its autonomous driving capabilities. Zoox is specifically aimed at the autonomous ride-hailing, and not immediately focused on Amazon's logistics operation for package delivery. Amazon continues to add versions of the original Kiva robots to more and more fulfillment centers. At the same time, the company works on new robotic inventions to handle new tasks inside its facilities. The company has also started introducing new mobile robots, similar in appearance to the original Kiva ones, to shuttle packages around inside sortation centers, which are mini warehouses where packaged customer orders are sorted by geographic destination. In these same facilities, Amazon is also experimenting with giant robotic arms that would place the ready packages onto the mobile robots. All the while, Amazon continues to chase the holy grail of warehouse robotics, a robot that can grasp a wide range of merchandise types with different shapes, sizes, and form factors, with a level of dexterity that's similar to what the human hand can do. Such an invention, though, could mean Amazon would need fewer workers working as pickers and stowers. That doesn't entirely mean that the warehouse workers are out of jobs. This year, the company announced plans to upskill 100,000 of its US employees, including warehouse workers. A spokesperson said that as the top US employer, the company feels a responsibility to help employees develop new technical skills to move into better paying jobs. In the end, we as humans have to adapt to the machines as much as the machines have to adapt to us. Our careers depend on it. The automotive manufacturing sector has seen this as most of the assembly line is prefabricated and assembled entirely by autonomous robots. The invention of the computer has also caused the loss of jobs. Basic skilled, repetitive tasks are being challenged in the current age of autonomy. With all this, however, new jobs and careers are being born to fuel and facilitate this demand. It all requires human ingenuity and adaptation as we transition into the next generation of technology. Thank you for watching this episode of Futurelicious. We'd like to hear your thoughts about Amazon's robotic workforce and the future of autonomy. If you've enjoyed this segment and would like to see more, consider subscribing and give the video a thumbs up. Like always, we can't wait to bring you more from the future.